Hi, everyone. Okay, so I do get it. I do understand it that there's not many people who said, "I can't wait to get that presentation about edge computing." Oh, wow, it's going to be so exciting. You know, this is not a particularly exciting topic to talk about, but it's very, very, very important. And we as a company, and so therefore our competitors, are pouring money into this. And there's a very good reason why. And so hopefully, at the end of this session, and I'll hopefully only take 25 minutes of your time, I'm going to try and get across why edge computing is so important and why we and our competitors see it as a massive area for development. And I'm going to try to talk about, it's very difficult for me to not talk about Lenovo and say, we're amazing, because I genuinely think we are, but I'm going to try and do it on a market base as opposed to us. So, even though that sounds like a really exciting title, I'm going to start off by explaining what edge computing is, because I guess there are people in the room who don't know what edge computing is. And essentially, really, you could boil it down or slice it a number of ways. We used to call it industrial computing, data acquisition, data analytics, making fast business decisions where we call it the coalface, I suppose, where the data happens. And that's what it's all about. It's taking a tiny chunk of the cloud, the ridiculous performance that we have in the cloud, but it could be in another country, it could be miles away. There's latency, it takes time to send data there and back. It's taking a tiny chunk of that power and putting it right where the information happens. So you can make very, very quick business decisions, leveraging AI, of course. There we go, we've said it. You get your AI bingo. We have to mention AI. We're contractually obliged to go on and on about it, but AI actually is really part of this sort of computing style. So, as we say here, compute has always really followed the data, and actually it's quite interesting. And I'm sure no one in this room is as old as me, but I've been in the IT industry since the early 90s. Can you believe it? And we've seen data go from centralized to decentralized, decentralized to decentralized. And it was quite amusing when the cloud came out. I do remember I had a friend of mine saying, "Oh, I just love the cloud." I'm like, "But what do you mean?" He said, "Just the cloud, I just love it." I'm like, it doesn't make any sense. Yeah, the cloud is just someone else's computer at the end of the day. But this is really important because it doesn't matter how powerful your data center is, there is a networking latency to send information from the coalface to the data center and back again. And this is a really good example. Well, actually, it's a bit of it's not the best example, but it's one that I use. And it could be if we look at Amazon or other massive global retailers / logistics companies are available. But say you had a line of boxes that you're sending out to customers for whatever reason, 10 a second down this one line, loads of lines, and you want to check each box to make sure that they're not damaged because you don't want to send out a damaged box. Obviously, to do that with human interaction is difficult. It takes time and it's costly. And also, humans were probably the reason why it's damaged in the first place. So you want to do it in an automated way. So you take a picture of each box from each angle and send it off to a data center. Well, you can't really do that. The data center just sending that big information, pictures are very big in terms of data, just sending that information and getting it back with a decision if it's okay or not will just take too long. So we do that at the edge. We put in a system that has advanced processing capabilities. It could be AI. It doesn't have to be AI. It's just I need to say it a number of times to get paid. It's just very, very powerful, and it does it there and then, and it does it quickly. And instead of sending it, all that information to the data center, it just sends a report saying, out of like the last 100,000 boxes, 2 have been damaged. So you still get that business data analytics, you still get that information, though in a simple report at the end of the month. So it's computing capacity at the coalface It's close to where the data is generated, and it's quite innovative in terms of its technology. But the interesting thing is, if you start looking at the stats, it's quite incredible. Only 2% of data that we create is processed. And so it's all about the data. It's not about the hardware. And for a long time, I feel Lenovo and our competition have been about the hardware, but that's the least important thing in some ways. You know, it's about the data. It's about making your organizations more effective, faster, and more efficient. Now, normally I wouldn't do this. In fact, I hate showing videos at presentations. I just think it's a bit lazy, but that's exactly what I'm going to do right now. And it's literally just 20 seconds long, but this is a company that we worked with that used edge computing, and it's just a great example of how stuff works.
We fish more than 75,000 tons per year. We are the largest fleet in Latin America, which is why efficiency is the most important thing. Tuna fishing is a complicated process. You have to be locating, chasing, and capturing it. A tuna never sleeps. We wanted to get away from precarious processes, such as the spreadsheets that were used, and that is why we chose Lenovo. Lenovo Edge servers are so compact that they fit into the small deck of a ship. And they are tough enough to withstand sea conditions. Thanks to Lenovo, we can process thousands of records in real time that help the company's decision-making. Our fleet is better coordinated than ever.
Lenovo. Now, there's two things I take from that. One is our ridiculously cheesy tagline at the end of it, Lenovo, Lenovo. But every time I hear it, a bit inside of me dies. And the other thing is, tuna don't sleep. They never sleep. I never knew that. But the interesting thing is, that company, they had to do this processing without internet connection. Of course, they're out at sea. You can't guarantee an internet connection. So they have to do everything fast. They have to do everything using computer vision. And they have to have systems that are immensely strong and immensely powerful. And also use different voltages. They use DC, AC, everything. And so these systems can do that. So this is what we're looking at, the drivers for edge computing. And it's interesting, we talked about this the other day, me and my team. We were trying to find a vertical organization, type of organization where edge computing wouldn't be appropriate. And anywhere we think where there's data acquisition, I mean, even just from digital signage, anywhere where you want to deploy a system, chuck it up in the roof, you know, never touch it again. You want it to be running 7, 8, 9 years, no fan, covered in dust. You never want to touch it again. You just want it to work. And that's where edge computing comes in. So if you have any issues or any an environment or a business environment where you need fast decisions made right where the data is, then edge computing is for you. We're now seeing, this is quite interesting, consolidation of workloads. So you may have a retail organization, and you may require computer vision and digital signage, communication, security, or whatever. And you can actually sort of aggregate these into one powerful unit that you know is going to be very reliable and last, instead of you go for lots of low-cost units, but ultimately, if you're sending people out to fix these units and repair them all the time, that costs more than just this consolidation into an edge unit. And then the other areas I mentioned, AI. The interesting thing about AI is, and I'm very sure, in fact, I know you did hear about it earlier on, and you probably hear about it every day. Today is day one. Okay, so if you are doing a deployment, if you are investing in IT, it genuinely makes sense to consider AI and local and neural processing unit performance, because you might not use it today, but this device is going to be with you for like 7 years or something. You probably will be using, in fact, you'll 100% be using AI within that time span, within a couple of years. So you want to have a system today that you're not going to have to replace in a year or two. Now, it does have unique requirements. One is, I don't know how many of you have been into a data center before, but this is server architecture. This is a very, very high spec systems that use like solid capacitors. As I mentioned, there's no fan. It's designed to run 24/7 for years and years and years and years and years. And I don't know if you've been into a data center, but my word, they are loud. I mean, I was lucky enough once to go to I remember the last data center I was at was the CERN, the particle accelerator. And even with ear defenders on, it was just impossible to talk. They are so, so loud. Because actually, something like 50% of the power used in data centers is just to cool the CPUs. And that's sort of in fans and pulling the airflow through. So they have to be quiet. So fanless. And even our most powerful edge systems are fanless. They have to have shock and vibration. They need to go from minus 20 to plus 60 in terms of temperature. And it's not just temperature variance, it's what we call temperature shock. Because this could be, if it's in a roof, it could go from minus 20 to plus 60 in the course of about half an hour. So it has to be very, very, very strong. Security is absolutely key, because this is personal data that you're taking on these devices. And so, for instance, our units, if you open them up, if you take a screwdriver and open it up, it will automatically wipe itself. You will use a secure wipe, so all the data's gone. It needs to have tamper detection, if someone picking it up, it needs to have a report sent to the Central Security Office and so on. Flexibility, I mentioned the ship, and that's the stunning thing. Yeah, you can power this one in particular from USB-C, or you can power it from DC or AC or whatever, but the power fluctuations it can deal with. So we need the ability to stick it on the wall. It needs to go into rack mounts, or, I mean, half the time these are literally in cupboards. So it needs to have this flexibility in terms of its deployment and installation. And I've got here management, of course, but there's no point deploying 1,000 units that go on, I don't know, on a road network, for instance, and they're all over the place. If you can't get to them, and if you do have to fix them, you want to be able to manage them remotely. So this single pane management is really important. And then the last thing, and it shouldn't really be the last thing, it's something that we put into mind with every single step of our design process for any product now, is sustainability. We made a very public commitment to our roadmap to net zero, and it turns out it's blooming difficult. But we've made it, and we've said it, and we have to follow through with it. So we use up to 90% recycled materials, and we try and asset recover the previous units we sold and recycle them, repair them, reuse them, and so on. Now, in terms of the markets, so hopefully I haven't bored you too silly about edge computing, but I just want you to know how big the market is, because I've talked to people before and they said, yeah, well, it kind of makes sense, but it's not really in my vertical. And you're like, well, it is. It might not be in your organization, but your competitors are using it. Your competitors are thinking about it. There's been a lot of talk about taking the processing power back out of the cloud, which is very expensive. You might have connection issues. You might have security issues for very particular types of data. So there's been a lot of talk about people putting it back at the edge. So we're looking at, by 2025, 2.6 billion devices, and these are just the edge units with AI processing capability, which is a small fraction of them. So this is a massive market. Please, understand this is a huge, huge market from us, from our competition, whatever. It's a massive, massive, massive market. And there are some verticals that really lend themselves into edge computing. And this was, as I mentioned, retail, but of course, manufacturing and or hospitality, the food industry, smart cities, which is one I'm going to talk about in a moment, These are main sort of areas where we really see obvious uses for edge computing, because you need this hardened computing where the data happens. Okay, so I mentioned manufacturing. These are real companies that we work with. In the US, the first one, we work with them. They reduced downtime to 45%. Actually, I tell you what, instead of going through all these stats here, let me show you some specific examples, 3 examples. So this is a industrial manufacturing company in the US, and they have, considering the US, you think these guys are very, very, they're very strict about their health and safety and so on, but they're having a surprising amount of injuries within this large company. And we used an edge system for very, very rapid computer vision, and it was doing facial recognition and people recognition. We worked with a very large plane manufacturing company. I can't say who, but they're very, very, very big. And it's quite interesting. I didn't realize that some of the tools they use, some of the calibrated tools that they have to use within their regulation when doing the repair and servicing of planes are worth an insane amount of money. And people were losing them, not because they're not stealing them, sell on eBay. I mean, this like a particular tool might be worth $100,000, but it's not like you can sell it on eBay. But they were just losing them because they go out for a smoke with their friends and forget where they put it. And we're using computer vision to track the tools within the factories to know exactly where a tool is at any one time. It helps with regulation, it helps with auditing, it helps with health and safety, of course. Another area, and this was actually the one I was most interested in. So this is a company in the Nordics, and they were looking at, because of their location within Europe, they have a lot of invasive species of flora which go onto the side of the roads and they sort of ruin everything. And the way they were doing it before was basically people in a car with binoculars driving very slowly. And they say, yeah, I think I saw one there, I think I saw one there, and they'd have to go back and check it again and again and again. Now, we could get PC in the car. It's got computer vision. It can work from DC voltage. It works with vibration, dust, altitude, fungus ingression. I mean, all sorts of things. It just keeps on working and working and working, connected to a car battery. It takes 20 pictures a second. Can work out within a fraction, like if there's an invasive species or not, and then tag it. I mean, this saved them an insane amount of money. Another one was the fishing video we saw earlier, and the interesting one about this was the main thing I took from it, as I was saying, is they don't have internet connectivity. So this was, you just have to have an industrial computing solution. And in terms of marine law, there are some very, very difficult standards to adhere to. In terms of, normally we go for CE marking across Europe and the UK CE mark, and then you have to hit certain standards for dust, vibration, altitude, and so on. But the marine rules are extremely difficult to hit this requirements to actually put this kind of equipment onto a ship. But it's the amount of money it's saving is incredible. And that's what it's all about. At the end of the day, isn't it? Let's face it, it's saving money. Efficiency, saving money, getting competitive edge over your competitors, just being faster to make those critical business decisions. And then this is actually an old slide, which is why, and my apologies, these GIFs are probably the lowest resolution you've ever seen. But this is a very, very old slide that I put into a presentation when talking about Internet of Things to a number of local government bodies about 5 years ago, but it's still the same today. Smart city projects are really, really important, and they're the perfect solution, or the perfect application for industrial computing, data acquisition, fast decision making, because You can, if you look at Dublin, if you look at Barcelona, where the entire city is run on Lenovo architecture, they have deployed these products, they've invested this money, but they've saved so much money literally within a year. They've paid for the products, the technology they've installed, and they're going to carry on reaping those benefits. Because now, when a bin gets almost full, it sends a message to people saying, come and pick me up. So they don't have a fleet of people going around with, like, looking at empty bins saying, oh, what are we doing? They don't have a city where bins are overflowing because they didn't realize they were overflowing. They can be fast, efficient, they can make critical business decisions. It hasn't done anything about the pickpocketers, unfortunately. But in terms of everything else, they've saved so much money. So, who are the players? Well, we do have our competition, unfortunately. But like any market, it's really important, really beneficial to have competition, because competition means innovation, and it means that we're all working harder to get business. So Dell, HP, Supermicro, I won't mention their share price, and Advantech, these are all people, big players in the market. We do feel that, of course, I'm not going to say, we're small fish. I'm always going to say we're huge, but we do feel that we have the upper hand with these guys. We have a massive range of products, and the interesting thing is, so if you talk to people at Lenovo, we kind of split into two organizations within Lenovo, and one will be the client, what we call the client device side. So laptops, tablets, visuals, accessories, workstations, pretty much everything on that side. And the other side is called what we call ISG, which is servers, infrastructure, storage, and so on. All of it underpinned with services and solutions. But Edge is quite different, because Edge spans everything from one side to the other. We have our very small boxes, the one that I was waving around just now, from the SE10 all the way up to the big data center boxes, powered by a number of architecture providers. And it's a massive range, but they all have this industrial capability. They're all quiet, they're all designed to go from extreme temperature ranges. They're all bristling with connectivity, which is really important, of course. You could have, if you have a box which is doing data acquisition and visual analytics in a ceiling somewhere, in a retail store, you want that to have 4G, 5G, LoRa, Wi-Fi connectivity, and so you have all these options available. Right, last couple of bits from me then, really. It's one thing to say, and I've got to say it again, AI. You know what? We did this presentation in Newcastle the other day, and saying AI a lot in Newcastle, it was quite difficult without trying to do the accent. But there's obviously AI is really important to us. And the interesting thing is Lenovo is the only company where we have what we call pocket to cloud. And it's a phrase that we use a lot. But it is quite important, because we have everything from phones all the way through to data center and everything in between. And as you can see, the Edge is a very important part of this portfolio. But all of this is underpinned with solutions and services. But honestly, we don't sell direct. That's why it's so important. We work with Beckler, as such a great partner of ours, and they can do the little bits that are really important for you guys, and we just do the sort of the heavy lifting in terms of making the products and getting them sent out. But we do work with over 50 solution providers for AI capability, and we can bring these guns to bear according to whatever your requirements are. And in fact, this was really surprising. I didn't realize this yet. I was presented to some investors the other day in Canary Wharf, and I only picked this out the other day, but we have 25% of people that work at Lenovo are based in research and development in one way or another. 25% of people. So we actually invest more in R&D as a percentage of revenue than Apple, and that's why we've been picked as the #1 best workplace in the world to work for AI and robotics. Frankly, this list here, I mean, we're above, where is it? The Moonshot Factory, that's the Google Skunk Works. We're above them. Even if we're number 10, I'd still show the slide, but we're number 1, which is phenomenal. Okay, my closing slide, I just want to say that the things to remember about the edge, if you have any requirements within your organizations where you need to crunch data fast and make those big, fast, important, crucial business decisions that can give you the edge over your competition, then edge computing is the way forward. We have particular devices. You can't just put a normal PC or a normal server under these conditions. You have to have the right product, the right software, the right management in place. And the last thing to say is, Lenovo, we used to, we used to just, technology for technology's sake, used to spit out hardware and think technology is key. Technology is the thing to sell, but it's not actually the case. Technology and insights, outcomes equals value, not just technology for technology's sake. So I think I've heard enough about edge computing, probably more than you ever wanted to hear about edge computing. But just one thing to say is, if you do have any questions at all, please come downstairs. We're at the stand downstairs, and we can answer any questions at all. But that's it. Thank you very much for your time. Thank you.